5.1D, which is about inverse trig ratios. So we use the inverse of our trig ratios to find missing angles. That is the really big thing that you need to remember for this section, is that we use inverse trig to find angles. We use regular trig to find sides. So I would recommend, in real big letters right here, you just write use inverse trig to find angles. You just got to remember that. You might find today that you're like, oh, this isn't actually that hard, which it's not. It's a pretty simple thing to do. But you are likely to forget that this is what you're supposed to do when the test rolls around if you don't kind of look back and practice it and remember it, okay? So let's go ahead and jump into example 1. So on example 1, I kind of covered it up, but you can see one over here also. They're going to have an angle marked with a little symbol here. And this symbol is called theta. It's a Greek letter. It's the symbol that we use to represent an unknown angle. If I had an unknown side, it'd probably be marked with an X. But when we have an unknown angle, instead of an X, we use theta. So here, theta was marked on angle B, and that tells me first that that's the angle I'm supposed to find. And also it tells me what my focus angle is. So from angle B, 2 sides are labeled with numbers. The hypotenuse is labeled and the adjacent side is labeled. So using SOHCAHTOA, I know that if I know the adjacent and the hypotenuse, that's a cosine problem. But I'm not going to do cosine. I'm going to do the inverse of cosine, which looks like this right here. It looks like cosine with an exponent of -1, but that's not really an exponent. It's more of just like a notation to tell us that this is the inverse. So normally I would say cosine of theta equals, and the thing that's a little different here compared to what we've done before is that we know both numbers. So it's 3/9. But what that means is to find theta, we can do the inverse of cosine. And what we do differently is we input the side ratio. So before today, next to our trig function, so sine, cosine, or tangent, we would put an angle. And the output over here would be the side ratio. 3 would be a side, 9 is a side. When we're doing inverse trig, it flips. So with the cosine, we put the side ratio, and the answer we get is the angle. So that is definition of inverse right there. Inverse functions swap the input and the output. So you can see that example right here. So now it's just a matter of typing it in your calculator. So I'm going to type in second cosine, and if you look above the cosine button, there's a little inverse cosine symbol right there. So we should see that cosine with the -1 pop up with an open parenthesis. Then I type 3 divided by 9. And honestly, you don't have to close the parenthesis, but I'm just going to go ahead and do it. And I get 70.5. The directions do say round to the nearest tenth, so I'm going to write exactly 70.5. And I'm going to put a degree symbol on that because that's going to reinforce the idea that I'm finding an angle here as opposed to all the other trig we've done so far where we just found sides. All right, so let's take a look at number 2. So number 2, the theta is marked at angle A. So that means 14 is my opposite side and 7 is the adjacent side. Opposite and adjacent uses tangent. So I'm just going to kind of skip the top line that I did here with number 1. And I'm just going to say the inverse tangent of opposite over adjacent, so 14/7, equals theta. So I'm going to type that in my calculator. Second tangent, 14 divided by 7. And I get an answer of 43.4. And again, I'm going to the tenths place, so I'm just going to stop there. I mean 63.4 degrees. And now the last one. So this is my focus angle here. I'm supposed to find angle B. So opposite of B is 12. And 14 is the hypotenuse. So opposite and hypotenuse is sine. So we're going to do inverse sine of 12 over 14, opposite over hypotenuse. Go ahead and type that in. 12 over 14. And I get 58.997. So this is kind of a good rounding example. So this 9 would bump this 9 up to a 10, basically. So that means we're just going to put 59 for our answer because it's kind of like a chain reaction rounding situation. So that's actually going to be 59 degrees. So there we go. So that's the gist of what you're doing today. Let me know in class if you have any questions or if I can help you out anymore. And I'll see you in the next lesson.